crush thy
here we
end
go.
is now.
If we check out YouTube now, it should be streaming in-game with our voices coming through. Will anyone be able to confirm in Minecraft chat?
Surely. Yeah, surely we play the FNAF 2 song.
It is? Perfect. Mixel?
Yeah,
assume
I
that's
can
your
hear
Perfect.
everything twice now.
Hello, stream. Everyone
Oh my
coming
God,
in
this
the
is-
future are here now. The future
Hello.
people.
Can people hear us now on YouTube?
Yes.
Oh,
There's
hell
a
yeah.
bit of live stream delay, so everything anyone says just like comes straight back to me. Oh my God.
Yeah, I recommend turning off the audio for the stream for the speakers.
Yeah, okay. It's all. Yeah.
Okay, I suppose I should start getting all the slides into position. Oh, hang on. Did we wait? Both of our slide changing's working, right? So that
Yeah, it's
that
working
must
for
be
me.
fixed.
Slide changing.
Yeah. Okay. Cool. Oh yeah, fun tidbit for the audience to hear. We've got a client-side mod that we can set up to put a keybind to a Minecraft command. So that's how we're changing the slides. It's a neat tidbit. Actually, yeah, that's another thing to shill. Asteroid client is on my Modrinth. Check it out. Yeah, I'm just shilling everything. It's self-promo time. Is it? Minecraft is an amazing game, not containing bottles of water.
It does have bottles of water though, doesn't it?
Yeah, it does. It literally does. Asteroid is a fork of Meteor Client, but with all the cheats removed so that it can be on Modrinth. So it still has like utility functionality, but no like cheap hack client modules kind of.
Yeah.
Oh god, it's starting soon. Okay, the nerves are kicking in.
Yeah.
Oh, look at all the pixel people.
When the Discord event starts,
watch the voice go
start.
tremble real.
Yeah.
God.
So yeah. We'll see how this goes. Once again, it's like we're two people, so we'll see how this all works. Hopefully it works out fine.
Yeah.
Yeah, but SwitchCube, your panel is next, so the Goosebumps does make sense. Oh, so everyone make sure to go check out SwitchCube's panel afterwards. That's next up. And it literally is like half an hour after our panel time, so you may as well stick around.
Sure.
Yeah. We do have some of the weirdest time slot because time zones and stuff. Yeah, turns out that the rest of the world runs on a different time than Australia, which is a bit
By the way,
sad.
the event's just...
Okay, I better stop saying random stuff.
I am so incredibly incompetent when it comes to Discord events that I don't exactly know how to start
I
it.
think... Let's see.
Does it auto start, or do you have to press a button?
No, it says starting... No, not that one. It says starting soon. Yeah, I mean, I don't have permission to do that.
Let's see. I think I've got it.
Okay. Let's get...
Beeps if you're in VC. I don't have that option.
Okay, so we're starting in a minute, right?
Yeah, we'll... Sorry for the delay. It seems that the Discord event is not able to be started due to permission issues. So I think, sadly, that will not work. What I'll do is I'll send a little quiet announcement. And I will let you guys begin. I'm going to head out of...
okay, I'm turning chat off. I can't have people saying Poglin
good luck.
halfway through.
Yep. Okay, so yeah, I guess... Mox, do you want to start us off?
Okay. Hello, everyone. Welcome to our panel on Designing Zoglin. So we, GMDU, we made a programming language in a data pack, and now we are making a programming language for data packs.
Yeah, so the idea of Zoglin and a datapack preprocessor, obviously, it's not unique, it's not original. There are plenty of datapack preprocessors like this one, JMC, or JavaScript-like MC function, and that allows you to write JavaScript-like syntax for MC function and do constructs like for loops or if statements and stuff like that. There's also MC build, which if you watched the talk yesterday by Kano Karob about log.zip, that he was talking about how they use MC build for their projects. So that one's a pretty simplistic datapack preprocessor. And there's also one called Bolt, which lets you use Python in combination with MC function syntax. So why not use one of these? Well, when you're writing a program or a datapack, there are a few things that need to really fit together to make it a smooth experience. So everyone's brains work slightly differently. Everyone thinks in a slightly different way, and different languages also work in different ways. And if the way that your brain works complements the way that the language works, then it makes it really easy for ideas to flow from your brain into code. Additionally, the language needs to fit with the program, right? Different tools are designed for different jobs. If you wanted to bang a nail into a wall, you probably could use a spanner, but you'd rather use a hammer, right? And so none of these datapack preprocessors that we showed really fits all three of these criteria. They didn't really give us the tools we wanted to make technical datapacks. They didn't give us powerful enough tools for specifically technical datapacks. And here, something else is there, partly because there are sometimes external factors that determine what language you choose, but mostly it's because I couldn't find any stock images with 3 puzzle pieces. I could only find one with 4. So can we do better than these datapack preprocessors for our specific use case? And the answer is I think we can. So yeah, Zoglin isn't going to work for everyone, but for us, we wanted to make our own one. And you can't bring up anything like this on the internet without showing this XKCD comic. But I think, given the fact that there really isn't anything that really fits the small niche we're going for, I think it's justified that we can make our own. So yeah, I'll hand back over to Mox Valex to explain a bit more about what technical data packs are and what we use this for.
So yeah, as Gears mentioned, we decided to make Zoglin, and we decided obviously to make it a technical data pack preprocessor, as that is really the kind of data packs that we make, right? So I'm going to now ask the question here, what is a technical data pack, right? So I kind of came up with 3 or so points that really explain what I believe a technical data pack is. Now, it doesn't necessarily apply to all of them. It's not fully exclusive or anything, but I'll go through them now. So the first point is that the data pack might be computation focused, right? So the data pack could be maybe implementing a sorting algorithm or parsing a string or doing anything that you would do in a traditional programming language, but doing it inside a data pack, doing it inside MC function, right? The second point is a technical data pack might abuse quirks of MC function to achieve certain goals, right? There are plenty of quirky behaviors that you can exploit in MC function using all kinds of weird stuff that Mojang has added, and you can achieve a lot through those. So there's that aspect to technical data packs as well. I feel like a technical data pack really pushes the limitations of the medium, right? Data packs are more intended for making like different game modes or doing world gen, stuff like that. And maybe doing more computation-minded tasks are less what the goal of MC function is as a language, right? So here's a good example of a technical data pack. This is Fungecraft by our good Gears over here. So Fungecraft is a Minecraft implementation of an esoteric programming language called Bufunge. Now, Bufunge is a two-dimensional spatial programming language, basically meaning that you write the program out in symbols and then execution follows these symbols along and branches based on what symbols are there. So in Fungecraft, instead of symbols, you use blocks. And this here is an example of a Hello World program, right? Written out in Fungecraft. Another example of a technical data pack is Moxlim. Now, this is a data pack that I made, and Gears did work on it later on, but it really is a library for making technical data packs. So as well as being a technical data pack, it's designed to help make technical data packs, right? And with Moxlim, I really set the groundwork for a lot of the different conventions and styles, I guess, like systems that we took into later projects and influenced a lot of how we ended up designing Zoglin itself. For example, Moxlib introduced this convention of namespacing data storages to the functions that use them. As well, a lot of the overall structure of the data pack is very similar to now what we use in our more modern projects, as well as what we've embedded into Zoglin. So yeah, I'll pass back over to Gears.
So what is Zoglin? Well, put simply, it's a technical data pack preprocessor, right? It's a preprocessor for data packs, which is designed for making technical data packs as we've made our data packs, right? And it's very geared towards our style of data packs. So in this talk, what we hope to do is summarize Zoglin and explain some of the language features, and as well our thoughts on how we designed the language and how we came up with certain features and what problems they're designed to solve. And I'll let Moxfelix go back and explain the basics.
Yeah, so we worked on a rather large project, Code of Copper, together. And this was actually the first project that we worked on together as GMDU. And it ended up spanning a year of development. Now, Code of Copper implements a programming language inside of MC Function. So you can write programs in a book and then execute them on a golem. If anyone's visited the Code of Copper booth here at Smith Summit, you'll be able to get a little demo of Code of Copper. But really working on such a large and complicated project taught us a lot about how important project structure is to maintaining a data pack, right? And this is because in MC Function, every single function is its own file, right? So data packs can get really messy. I'm sure if you've worked on, especially maybe some of your earlier data pack projects, things may have gotten a little out of hand with the amount of files that you end up making, right? So how do we avoid getting lost in this swamp of files, right? MC functions. And the answer really is to have a good folder structure and organization of your project, right? So to have a good organization of your data pack project, you need to have proper naming for all your functions. Now, this is fairly standard. This is consistent across every language. You want to have good names to represent your functions, right? As well, it's important to group similar functions together into a folder. This makes it a lot easier to find these functions. And the logical grouping just helps you have a better picture of your code base, right? And then maintaining a good file system hierarchy is the third point here. And really, it's a good idea to have a more general set of folders and then get more and more specific. And this allows you to organize your code base a lot better and easily find the files that you need, right? However, there are still some issues when making a data pack, right? you still ultimately end up with many folders and files. This is just inevitable as how MC function works, right? As well, it can be really hard to reason with your code base when it's split across all of these files, right? So how did we go about solving this in Zoglin? So Zoglin is designed to be flexible. You can define an entire data pack within a single file if you so wanted to, or you can as well split up your data pack across as many files as you desire, right? And to keep this project structure, Zoglin provides a bunch of language features to be able to do so. For example, Zoglin provides the namespace keyword. Now, a namespace is the root of any Zoglin project and, well, correlates to the namespace of the data pack itself. You can have many namespaces in a Zoglin project, and everything is nested underneath a namespace, right? So the next concept we have here is a module. So a module is a folder in a data pack, right? And modules are always nested under a namespace, and modules can contain other modules, or they can contain functions, right? So functions in Zoglin can be written out how you would write them in a typical programming language. And so functions are obviously nested under a module. And for example, this function here, bar, in the generated data pack, you would find that in the foo folder, as you can see here. As well, we have some other language constructs such as resources. These represent the JSON files in your data pack, like advancements, tags, etc. As well, we also have assets, and those generate inside the assets directory instead of the data directory, but they follow the same syntax. And then as well, the Zoglin also provides the include keyword, and that allows you to include another Zoglin file into the first file, and that allows you to split your project up amongst multiple files and be super flexible. So while these features aren't necessarily unique to Zoglin as a preprocessor, we believe that compilation transparency is.
So what is compilation transparency? Well, when you are making a data pack, right, in Zoglin, you will write some Zoglin code, also known as source code. And once you're finished with your source code and you want to test it out, you will put it through the Zoglin compiler, and out the other end will come MC function. And the idea of compilation transparency, as we coined the term, is that you, as the user, should more or less be able to tell what MC function is going to come out the other end when compiling the Zoglin code just by looking at the Zoglin code itself. And so, why is this important? When you're compiling a C program, you don't need to know the exact series of assembly instructions that the compiler is going to generate. And really the difference between that is that data packs are slow. A couple of extra assembly instructions isn't going to make any difference to your program whatsoever, but some extra commands, especially heavy commands like data commands or selecting all entities, and especially if they're in a loop that runs very often, they can make a real performance difference. And so when you're optimizing your data pack, you really want to be able to have full control over the output of the code, right? So you can know that your code is optimized correctly, right? And Kanokarab was also talking about this in MC Build and how that lets them have full control. We want to do this in Zoglin, but provide a few more powerful tools for this as well. So let's look at the basics of compilation transparency from what you've seen so far. So you can see here, this is something like one Zoglin file, right? You've got the namespace, you've got some modules and functions, and I've written above in a comment where these compile to. Now, as you've already seen, they compile to the place where the namespace is and the module and the function, and that means from the code you have full control of where a function generates, and from the code you can read off where that function is going to end up in the generated MC function. So you might be asking, what are the benefits of this and how does this help with optimization? Well, okay, slow down, let's take these one at a time. Well, the main benefit of this is easy MC function interoperability. And the reason that's important is because not all code is written in Zoglin, right? A lot of people are going to be writing code in vanilla MC function or other datapack preprocessors, and it would be really nice if you could take advantage of those other pieces of code and use them in Zoglin, right? So let's say someone's written a library in MC function, you might want to use it in Zoglin, or the other way around. You've written a library in Zoglin and someone wants to use it in MC function. Well, if we have something like this, right, we've got this function defined in some library and we want to call it from MC function, how do we do that? Well, it's easy. We just read from the code where it's going to end up and compile that in the function. It's completely transparent where this is going to end up, and so it's really easy to interrupt between Zoglin and MC function, and this would work the other way as well. And how does this help with optimization? Well, it doesn't. Yet. Because, yeah, knowing where a function compiles to isn't going to help you optimize your datapack, but it sets a foundation for the design of Zoglin, and when we start coming up with other features to actually generate code inside the functions, then we can use this to expand upon compilation transparency and ensure a consistent language. So I'll hand back over to Moxvalix to explain those.
Yeah. So keeping this concept of compilation transparency in mind, how do we go about designing the statements in the code? So this is really the bodies of the functions, right? So the first statement type that we have in Zoglin is a command. And now, as you can see here, it was very important to us that you could just write a MC function command right into your function, and that's how it would end up in the datapack, right? So you can see, for example, you can just write time set day, or optionally, you can also prefix it with a /. So / tell raw at a hello world, right? And both of those will generate exactly as you would expect into the datapack. Now, this is very important because having control over your commands allows for you to do these technical datapack hacks that you need, eke out any little bit of performance that you need, right? Because you have control over the commands in your datapack. Now, the next statement type I'm going to talk about here are variables. And this is really a very important aspect of Zoglin that we wanted to get right. Because we do a lot of technical datapack work, we work a lot with data storage as well as with scoreboard variables. So we wanted to be able to represent these different types of variables inside Zoglin and be able to use them a little bit nicer than it is to interface with them in vanilla MC function. And something that's important to us is that we could easily distinguish, we could infer the kind of the variable at a glance in Zoglin. So looking at this example here, right, we've got bar equals test, right? Now this represents a storage variable, and that is setting the MBT value of test to the data storage bar, right? And then we've got this $Baz, and that represents a scoreboard variable, and we're setting that to 123, right? And so we also as well have here a compile time variable. Now, this doesn't actually generate into the code, and we'll explain more about these later, but it's really just here to prove that we do have other prefixes as well that have meaning in Zoglin. It's just these are the main ones, right? And so now we can see what these have generated. So for example, the storage variable has generated this data modify command here, and you can see it set bar to the value test, right? And the same goes for this scoreboard variable. It's set $Baz to 123, right? This is exactly what you would expect from reading that code. But the next important point here is that the location of the variable, much like the location of the function, is really easily to predict, right? So if you have a look in this code here, we've got the namespace example and the function foo, and then bar baz, etc., right? And now you'll notice that the storage path we're setting to is example foo, right? And it's really predictable that bar is set in the example foo storage path. Same goes for the scoreboard variable. Example.foo is where we set baz. So these variables are very easy to predict where they will end up being, which is something that's very important to us. And then the third point here is that these 2 points combined means that it's super easy to use these from within your own commands that you hand write, as well as in any vanilla data packs that you end up interoperating with, right? So that is our variable system. Next, I'm going to move on to if and else. Now, we wanted to provide a nice way to do execution branching, right? And so the way that you implement an if-else chain in MC function is you generate different functions for the different conditions, right? So an if-else chain ends up generating a bunch of different functions. So we made a decision that we didn't want any Zoglin-generated functions to end up in any place that a user-defined function would show up. We felt that they should be fundamentally different things. So we have decided that we'll move all generated Zoglin functions into the Zoglin namespace. And in fact, this is why we ended up using the name Zoglin. Because Zoglin starts with a Z, all of these additional generated functions end up at the bottom of the autocomplete list. So that is why the name Zoglin. As well, we have the while statement. In Coda Copper, do a lot of iterating. We iterate over arrays, over we do all kinds of loops because, you know, we're working with a stack. And so it's very important as well. We had a while keyword, and that works similarly to the if statements, except creates a loop function. And then as well, the final statement type here is a function call. So to call a function, you can give the resource location of the function followed by parentheses, and that will generate to a function call in MC function. However, such a long resource location can get a bit unwieldy. So maybe there's a better way of doing things.
So yeah, let's talk about resource locations. First of all, what is a resource location? Well, we just saw an example of one, but more concretely, it is a piece of text which refers to a certain thing in a registry in Minecraft. So, for example, in this give command here, that Minecraft : diamond is a resource location. Or when you call a function, that is a resource location. And you might be wondering, why do we focus so much on resource locations? Because they're such a small part of MC function. But actually, when you think about it, you use resource locations quite a lot. Whenever you're calling a function, you need a resource location. Whenever you're accessing a storage, you need a resource location. So in a technical data pack, pretty much every command references a resource location of some kind. And so it's important to us that we settled on a nice, clean, ergonomic design so that they would be nice to use in Zoglin. Let's quickly talk about syntax, because a few datapack preprocessors use slightly different syntax. JMC uses dot syntax like this. This is more or less how something like that would be represented in JavaScript. And MC Build has some special syntax like caret for calling parent functions, star for calling from namespace root, and a couple other things as well. But in Zoglin, we really wanted to make our syntax as similar as possible to vanilla empty function. So we wanted to stick with the old faithful empty function resource location syntax, and that means that you don't need to learn an entire new syntax to write Zoglin, right? So one of the problems with resource locations, especially in the kind of data packs that we make, is that they can get really long because you have a lot of nested subfolders. This is an example piece of code from Code of Copper. You can't read it at this resolution, but you can see here underlined in red, that is one single resource location, and that is 85 characters long. Now, an 85 character long resource location isn't fun to read or write. Obviously, it's not fun to write 85 characters every time you want to use it. But also, if you're trying to read it, most of the information is redundant. Really, you just want to know the name of the function you're calling, because most of it is going to be the same as the function you're looking at anyway. So what can we do about it? Well, there's not going to be one universal solution that makes every single resource location shorter, because that would just be impossible. But we can find some common cases and figure out some nice shorthands for those common cases. Let's quickly look at what Minecraft gives us to shorten resource locations. And in Minecraft, there's really only one common case, and that is when you're accessing something in the Minecraft namespace. So in Minecraft, if you write something without a namespace, it just defaults to the Minecraft namespace as shown here. But in a technical data pack, that really isn't that useful because you really don't use the Minecraft namespace that much. You're mostly just calling functions and storages, neither of which are going to be in the Minecraft namespace. So let's go back to the drawing board and let's look at some common cases. The first one you've pretty much seen already. So when you're defining and accessing variables in Zoglin, if you so choose, you can write out the full path to the variable and specify the exact place where it will generate and where it will access. But again, that gets unwieldy pretty quickly, and really here all you need to know is that that variable is called A. And so what we made it is so that you can just omit most of the path, just give it a name, and all that will do is it will do it relative to the current function. That's partly for readability and partly to not quite enforce, but at least strongly suggest a convention of storing variables namespace to the functions which define and use them. Another pretty common case is when you have a structure something like this, where you've got a folder with several functions in the folder, and then a subfolder, and so on and so on. Now when you have something like this, the function calling usually looks something like this. So functions might call something in the same folder, or they might call something in a subfolder. So if we translate this into Zoglin, that looks something like that. But again, you probably don't want to know if something is in the same module as the current function. Really, it would be nice to just be able to see the path relative to the current module. So that's what we did. If you're calling something in the same module, all you need to do is just reference it by name, and if you're calling something in a submodule, you just start the path from the submodule. A couple of other things is that almost always you're accessing something in the same namespace, so if you omit the namespace, it will just default to the current namespace. And also, if you want to access something relative to the current module, you can use a tilde. This is the only place where we really strayed from the default vanilla MC function syntax, and that's because we'd really used up all of the other syntax from MC function, and so we had to create some of our own. But yeah, let me hand back over to MoxValex to learn a bit more about functions and how you call them.
Yeah, okay. So, in a typical programming language, there are really two aspects of functions that we take for granted, right? So, the first aspect is that you can pass arguments into a function call. So, when you call a function, you can set some values in there, and you expect the function to be able to use these inputs, right? And then the second assumption with a function is that you can get a return value from the function, right? So let's have a look at vanilla MC function functions. So as for arguments, we kind of have arguments with macros, but they're not really. They don't behave like a typical programming language's arguments for a function. And they can be, a bit weird to work with, right? As well, vanilla functions do allow you to return a value with /return. But there's a couple problems here. Macros are slow because Minecraft has to recompile the code or reparse it. And as well, as I said, don't really act the way that you would expect a normal argument to behave. As well, /return isn't the best option either because it can only return an integer value or a success or fail, and that's fairly limited as to what you can do with it. So my verdict is it kind of sucks, right? So how could this be better? Well, arguments should be able to take in any type, right? You should be able to pass in a scoreboard variable. You should be able to pass in an MBT from a storage, right? You want to be able to pass in different kinds of arguments. And then as well, you want to be able to return a scoreboard variable. You want to be able to return a storage, any arbitrary value, right? This would be great. So in Zoglin, we have implemented some special functionality and conventions for calling a function with arguments, as well as then returning a value. So up in the top here, you can see this special add function, right? And it takes in a scoreboard variable of A and a scoreboard variable of B. And then you can see it returns A plus B, right? And then down here in the test function, we are calling add. So we're adding 1 and 2, and we're storing that into the result, right? So we're assigning that to the result storage variable. So now you can see how Zoglin actually generates this code. So as you can see here, Zoglin has set $A in example.add to 1 and $B in example.add to 2. Now this may look familiar. This is exactly how Zoglin assigns variables to begin with. And as such, it means that these variables can be used inside that function, like any other variable. So we get this really clean abstraction here based on the existing variable system. And so now we call the add function. And then you can see here, we are storing into the result variable here. We're storing from this special variable over here called return. Now, Zoglin has a convention that it will, anything that gets returned gets stored in this special return variable, and then it knows to read from that variable to assign it to other things and use it elsewhere, right? Okay, so I'll pass it back over to Gears.
Yeah, so now that we've learned about regular functions and how you call them, let's talk a bit about compile time. So, okay, let's say you're writing a datapack and for whatever reason you want to summon 5 zombies, right? There's a few ways you can do that. For one, you could write a loop which iterates, counts to 5, and summons a zombie each iteration. Or you can just write out 5 summon zombie commands. Now, both of these have their drawbacks, right? A loop is probably going to be a bit easier to read and reason about, but it also has a lot of redundancy, right? You got to add a command for setting up the counter at the beginning. You got to add one for incrementing. You got to add one to run a recursive function. It's quite a lot of work just to summon 5 zombies, right? Whereas this is much more efficient, but additionally, it's kind of ugly to read. You know, it's just 5 identical commands in a row, and yeah, you wouldn't want to see that in a datapack. So what would be cool if we could do is something like this. So you have this code, it says do 5 times summon zombie. And what this really translates to is this on the left, but you get all the nice readability of, being able to say, okay, I'm doing this 5 times and summoning a zombie, but there's no additional performance cost, and you get all the nice performance of the left. So, before we talk about how this works in Zoglin, let's quickly take a look at some of the other preprocessors and how they handle this. So in JMC, I couldn't find a way to do something like that repeat thing, but there are a few compile time things you can do in JMC. So you have this define preprocessor attribute, or whatever it's called, and you can basically define a macro at compile time, and then whenever you use that, it will just replace it with whatever's on the right, just like you would do in a C macro. Additionally, there are these lazy functions, and what that does is whenever you call this print function, it will essentially replace that call to print with that tellraw command in the body, and it will replace whatever you put value in with, the value itself. In Bolt, you have a macro construct where you can take in some arguments and run some Python, and whenever you yield a command, it will essentially generate that in the output. And MC Build has a couple ways to do this. First of all, they have the compile time repeat keyword, which lets you repeat a certain set of commands at compile time. And you can also iterate over a variable. And as well, you can run arbitrary JavaScript code in this JavaScript block here, and that will let you do a similar thing. So, for what we wanted in Zoglin, we didn't exactly like any of these approaches too much. We certainly didn't want you to be able to write code in a separate language to generate Zoglin, or we certainly didn't want you to have to write code in a separate language, because there's two main issues with that. First of all, let's say we pick JavaScript like MC Build did. That means if you want to write Zoglin, you also have to know JavaScript. Secondly, it can lead to some, for example, security vulnerabilities, right? You can package a Zoglin project that, deletes a file on your computer when you compile it, and that's really not good. We really didn't want that. So after thinking about it for a while, we decided to take our inspiration for compile time from a different language, Zig. So Zig isn't related to MC Function at all. It compiles to machine code, but one of Zig's unique selling points is that you can run arbitrary code at compile time. You can just run any function at compile time, and you can use that to do things like reading in a file and bundling that in the generated output, or running expensive computations. So we really like this idea, and because it's all done in Zig in the same language, we wanted to use a similar thing in Zoglin. So we modified it a bit and came up with this. So here is a compile time function, and you can tell it's compile time by the fact that it's prefixed with an ampersand. So this repeat function takes in two parameters, command and a number, and it iterates at compile time. That's this ampersand here. It iterates over that number of times, and it just places the command in the generated output. And here you can see we're calling this repeat function with a command and a number. And I'll just note that a lot of this compile time syntax and design is still very much in the design process. A lot of this isn't actually implemented yet, but we have some basic stuff. Another cool thing you can do with compile time is something like this debug function. So we have this variable debug mode, and it's currently set to true. So this debug function, whenever you call it, it will check if the debug mode function is set to true. And if it is, then we are going to generate some code to debug that value. If it isn't, it won't generate anything. And what that means is that at any point we can just set our debug mode to false, and if we recompile the code, any of the times we call this debug function will just generate 0 code in the output, and we get 0 runtime cost. So that's really nice as well. The last quick example I want to show is a function from moxlib, which was sort of the original inspiration for this. This is the getBlock function from Moxlib, and this is a very simplified example. But in Minecraft, it's very hard to get the block at a position. You really have to check against every single block. And you can optimize it with something like a binary search tree, but for this simplified example, we'll just show these 3 commands. Now, you don't want to write this out by hand, and so what we've done in the past is written a script in a different language like Ruby or JavaScript or Python and generate that code. But we wanted a way to do this in pure Zoglin. So here's what we came up with. So you've got this getBlock function, and at compile time, it's going to iterate over all of the blocks in the block registry. And this at registry means it's a built-in function. Built-in functions are they're implemented into the compiler itself, and they allow you to do stuff which you can't express in Zoglin. So at registry will give you all of the values in the block registry, and basically it will just generate one command for each of them and just return that if it's that block. Now this isn't a binary search tree, obviously, and we haven't really designed a way to do binary search at compile time yet, but this is sort of a simplified example of how you'll be able to do stuff like that and iterate over registries and do all sorts of nice things at compile time. Now, if you're wondering about this ampersand curly brace syntax, I will let Moxvalix explain that.
Yeah, so next up we have inline expressions, right? So compile time variables are all very well and good. They're very nice, but they'll be a lot more useful if you could use them within the commands that you write, right? So in Zoglin, we have this special syntax for an inline expression. And this allows you to essentially write in code that exists at compile time and then have it generate into your command that you've written. So for example, the top example here, we've got the ampersand value compile time variable, and that will place that value into this data modify command here, right? It also works for function calls. So you can see here we have a function call to the baz function, and what that will generate is the text function and then the path to that function. So that makes it easy to use it in schedule commands, in anything where you need the phrase function and then the path of the function. Also good for execute if, stuff like that. As well, it also will expand out resource locations. So it allows you to use Zoglin's nice resource location syntax, and then that will work in your command as expected, right? And so here's a good little example of why these inline expressions and compile time variables are so powerful. So I'm sure all of you have at least used a UUID in a data pack at some point. It's far more efficient to refer to an entity by its UUID rather than using a selector, because then it doesn't have to iterate through all of the entities. It just knows exactly which one it's talking about. So you can see here we've got 2 variables. We have display and we have marker, right? So now display refers to a display entity's UUID. So this is a hypothetical entity that we've summoned in. And then this one, marker here, would refer to a marker entity. And so now it's very clear what these subsequent commands are referring to, which entity they apply to. So data modify entity display, you got a pretty good idea that that is going to be modifying the entity data of the display entity. And the same for teleporting this marker, right? So it just makes the code a lot more readable and a lot easier to work with.
Okay, so yeah, that has been an overview of Zoglin and our design choices when we were making it. But Zoglin is very much still in development. So what's next? Well, there's a few major things we have planned for Zoglin. One big one is the language server. So a language server is basically what's responsible for stuff like autocomplete when you're writing code in a code editor. So when you're writing MC function here, I've just written the function keyword, and it's now giving me a list of all the different functions I can call, and I can just click through them and select the correct one. So this is Spyglass, and Spyglass knows all about MC function and how to provide helpful suggestions, but it doesn't really know about Zoglin, and so that's why we want to make our own language server for Zoglin, which hopefully will be able to integrate Spyglass for the pure MC function, and then we'll have some custom behavior for other stuff. We also want to make a standard library, so that's basically going to be a library of useful functions. It's going to be heavily based on Moxlib, but we're going to add some nice new features, and we also want it to be compatible with vanilla MC function, so if you want to use it outside of Zoglin, you'll be able to as well. We also really want to improve compile time because a lot of the concepts aren't fully fledged yet. We're still deciding on a concrete design for them, but we really want to make it as powerful as possible and fill out this feature. And yeah, there's more. Like, there's a few more ideas we have floating around that we want to implement at one point. And yeah, if anyone wants to try out Zoglin and they have ideas for how we can improve it, please let us know, either in our Discord server or via an issue on GitHub. And yeah, thank you for coming to our talk about Zoglin. You can check us out on our website. There'll be links to Discord and stuff like that there, or you can download Zoglin. We've released an initial alpha for you to try out. So if you go to this link here, I'll send them in chat. There you go. And yeah, so thank you. I think we have a bit of time for a Q&A. We've got about 10 minutes or so. So does anyone have any questions?
I just want to pop in and say thank you so much for this wonderful presentation. And as you just said, let's move on to a Q&A. Questions can be asked through Minecraft chat and Discord voice text chat, as well as YouTube comments. And Mox and Gears will be taking that away for the next 10 minutes or so. And yeah.
Yeah. Give me a second. I just got to get all of the things open so that I can see the different questions as they come in.
Okay, I got a couple already. Okay. So this one was asked right at the beginning before we started the panel. What was the hardest thing about making Zoglin, and what was our favorite thing? Well, I can go first. And yeah, I think the hardest thing, honestly, I think my answer to both is compile time, right? Compile time is quite a complex thing because we've got to be able to run Zoglin code and generate code based on that. And yeah, it was quite a challenge to implement what we've done so far, and there's definitely a lot of work to go. But it's also one of my favorite features. I think we settled on a really nice design for the language. Do you want to say something, Max?
Sorry, I was still setting things up. What was the question?
Our favorite feature and the hardest feature to implement.
Favorite feature? I think my favorite feature